Today we're going to start talking about factoring trinomials with the a value equal to 1. This should be a review for you. This is an Algebra 1 skill that we have, but it's been a while, so let's dive into this. All right, this is a little system of factoring that students really like. I'm not really a huge fan of this, but it doesn't matter what I want. If it works for you, it works for you. And what we're going to do is find two numbers that add up to be 13 and multiply to equal 36. Now, there are an infinite number of terms that can add up to 13. Infinite. I mean, we could go, 326 minus 13. That equals 13. Now, the numbers that multiply to equal 36 are a little bit smaller terms. So what we want to do is focus on the factors of 36 that will add up to 13. Well, 36, a lot of you are going to be really good at this, and some of you are going to need some work. So we go through these processes: 2 times 18, 3 times 12, 4 times 9, and 6 times 6. Now, we don't want to go the other way, otherwise we'll just see the same terms but backwards. We'll see 9, 4 instead of 4, 9. So what we want to do is identify which of these expressions, which one of these factors, add up, they multiply to 36, but also add up to equal 13. Well, in this case, that would be 9 and 4. So this is what the X game is just getting you in the habit of finding the common factors, or the, common multiples, and seeing how much they add up. Now, if you put 9 in the front, 4 in the back, it does not matter because these two terms will work either way. Now, let's take a look at the next one. 48, different ways to get 48. And again, some of you may be, well, it's 6 and 8. Okay, great. I'm happy for you. That's fine. You do not have to write these out. Some of you may not be as good at these, so maybe you do want to stack these out. So 2 times 24, 3 times 16, 4 times 12, 5 doesn't work, 6 times 8 is where we get our answer. Now, we need this to multiply to equal negative 48 and also add to equal negative 2. So in this case, one of our terms needs to be negative, and it needs to be the larger term because our result is negative. So our values would be 6 and negative 8. And then I chose this last one because sometimes I have students that have some difficulties with factoring the values like this. Now, the factors of 9 are 1 times 9 and 3 times 3. But a lot of times when we get these consecutive terms, we forget about the 1. 7, 8, 5, 6. Any consecutive terms, what you're needing to use is the term and the factor 1. 1 times that number. So the one we're going to use here is 1 and 9, and we need them both to be positive. So this is called the X game, or whatever it's called. If this is a form of factoring that you like to use, go for it. I've had a lot of students that have some success with these. Maybe you'll be one of those. All right, so here's where we use the X game in actual factoring. What we're going to do is we're going to split this trinomial up into 2 binomials. And here's one thing I know for certain. We're using the a value equal to 1, if you notice that in the instructions. So everything we have today is going to have a leading coefficient of 1. But the first thought we should always have is find a GCF. Well, if the a value is 1, there is no GCF. The GCF is 1, so we're done with step 1. So we need to split this x squared up. Well, there's only one way to split an x squared, and that's an x in either side. And we also need to split up this 48. We need the factors of 48 that can become 14. And again, if you need to write these out, you write these out. 2 times 24, 3 times 16 still. We just did this one. 4 times 12. 6 times 8. So the numbers that can become 14 by adding and 48 by multiplying are the number 6 and the number 8. And we need both of these to be positive. So that is the factored form of x squared plus 14x plus 48. You're not sure, you can distribute these and see that it comes back to the original term. You can graph them and see where it crosses the x-axis. Another expression we have here, notice again, we're dealing with an a value of 1, so there's no GCF. It's x squared. There's only one way to split x squared. And that's an x in either side. So the factors of 72 that can become 1, well, we know if it's going to become 1, the two numbers have to be consecutive. So we could go through all of these, but I know these aren't going to work because these are not consecutive terms. 4 times 18, 8 times 9. And there's our consecutive terms right there, 8 and 9. So we know we'll be using an 8 and a 9. We also know that one of them is going to be negative because we need this to equal a negative 72. So how do we decide which one to give it to? It depends on what the term is. The middle term is a negative term. So the larger of the two factors needs to be negative. So in this case, that is 8. So this is how we factor our trinomial leading coefficient of 1. If you're ever uncertain, you can always distribute this back out and see that it does become the original expression. This one involves something we alluded to earlier. That is the consecutive terms. There is an exception to that when you see the 5-6 combination. What I mean is a 5 in the value for B, 6 in the value for C. But when we have 8 and our middle term is 7, our factor is usually going to involve 8 and 1, and that's the case in this as well. 8 does have factors of 8 and 1 and 4 and 2, 2 and 4. But the factors that can become positive 7 is if I had a negative 1 and a positive 8. So what I'm going to do is split this into two binomials. Remember, the x's get split to each one in the front. And the factors of 8, and again, the order doesn't matter on this. I can put the plus 8 in front and the minus 1 in back, or vice versa, just as long as the negative sign is attached to the 1 and the positive sign is attached to the 8. And our last one, factors of 90 that can become 19. If you're good with your factoring, you may be able to spot this immediately. If not, that's okay. We go through here and we look at the factors. By the way, I know a way that you can factor a number with a graphing calculator. If you were to hit y equals 90 divided by x, 90 because that's our value for C, look through the table and any integers that you have are factors of that number. You're either going to see, and the x and y values, if I were to look at this table, I would see 1 and 90. I would see 2 and 45 because that's a factor. I would see 3 and 30. And the next value on the table is going to be 4 and 22.5. So 4 is not a factor because its y value is an integer. But we could sit here and look through all of these values and see which ones work. Like I said, 4 does not work. 5 does work. That would be 18. We have 6 and 15. 7 is a decimal. 8 is a decimal. 9 and 10. And then after that, we just see a cycle of the repeating these in reverse. So the only factors that can become 19 would be the 9 and the 10. Now we need to multiply to equal positive 90, and we need to add to equal negative 19. So we need both of the numbers to be negative. We are splitting the x's up, we're splitting the 10 and the 9 up, and like we just said, both of these values need to be negative for this to equal negative 19, and this is the way that we factor x squared minus 19x plus 90. You have some examples to work on your own. Good luck.